Hello, welcome back. I thought I would simply continue trying out making videos for Advent of Code. Like before, I'm aiming for an audience that are kind of just getting into the idea of doing computer programming puzzles, while other people are sharing learned code, perhaps at the expert level. I will try to demonstrate some ideas at a more introductory or novice level. We'll be programming in R and just quickly going over the introductions again. I'm a data science instructor, and at the bottom left, I just want to um, upfront say that I'm not going for time efficiency, space efficiency, or the leaderboards. I'm just here to have fun. Alright, so on the right side of the screen, we are going to get right back into our Advent of Code adventure. Last we left off, we were in a submarine tasked with finding some keys that the elves had accidentally scattered in the sea. And we need to solve these puzzles along the way. Yesterday, we were analyzing the sonar systems, and at the top right, you can see that we are in day 2 called Dive. Reading off the prompt. Now you need to figure out how to pilot this thing. It seems like the submarine can take a series of commands like forward 1, down 2, or up 3. Forward increases the horizontal position by x units. Down increases the depth by x units. Up decreases the depth by x units. Notice that the folks who wrote this problem highlighted the words increases and decreases. To clarify what is meant by the word depth, but sometimes we puzzle solvers got to be careful about the physical orientation of the situation. Note that since you are on a submarine, down and up affect your depth, so they have the opposite result of what you might expect, like we just said. The submarine seems to already have a planned course, which will be your puzzle input. You should probably figure out where it's going. For example, note that your horizontal position and depth both start at 0. The steps above would then modify them as follows. Forward 5 adds 5 to your horizontal position for a total of 5. Down 5 adds 5 to your depth, resulting in a value of 5. Remember, the horizontal position and depth are different numbers. Forward 8 adds 8 to the horizontal position, so 5 plus 8 is 13. Up 3 decreases your depth by 3. Your depth was 5, decreases by 3, so now your resulting value is 2. Down 8 adds 8 to the depth, 2 plus 8 is 10. Forward 2 adds 2 to the horizontal position, 13 plus 2 is 15. After following these instructions, you would have a horizontal position of 15 and a depth of 10. What tends to happen with the way these puzzles are phrased from the folks who make these puzzles, it's easier for both us, the solvers, and the puzzle creators if the answer is just simply one number or one word. So that way we don't have to worry about things like spaces or punctuation. So even though we are talking about horizontal distance and depth, notice that there's going to be an emphasis on multiplying these two numbers together. So in particular, we're going to calculate the horizontal position and depth you would have after the planned course. The prompt says, what do you get if you multiply your final horizontal position by your final depth? Alright, so I'm going to go to my Advent of Code folder, and I like to start by getting some text documents ready to hold the input. Not required, but it's kind of an old habit. So I have an input file for today's date, December 2nd. And like what I did yesterday, I think once again I'm going to make another space for the example. In particular, in the example, I want to copy and paste these instructions: forward 5, down 5, etc. And being careful not to have an extra line or any extra spaces around the information. And then I'm going to open my input file, scroll down here to the bottom, get my puzzle input, and you'll notice that the instructions or the route of the submarine is quite more complicated. The whole point, or one of the big points of a computer programming puzzle, is it's most likely not something that you would want to calculate by hand. So I'm going to copy and paste that. Once again, making sure to avoid having extra spaces or an extra end line at the bottom there. And with that, let's go ahead and open up RStudio. Going to, like yesterday, make a R Markdown document. This is day 2. Before I get too far into this, I probably should save this. Clicked into my Advent of Code folder. I'm going to make a Markdown document with the date convention, and this is .rmd for R Markdown. In case I come back to this months or years later, I like to copy and paste all the instructions into my programming document for documentation. Have it all nice and tidy in one place. Now, normally the puzzle input will be handled by read lines. Like so. And I can see on the top right, it turns out our submarine had 1,000 instructions. The warning is RStudio's incompatibility with my anal retentive nature to avoid the extra white space at the end of the file. It's actually better for the puzzle solving process. But while we're coding up the calculations, I would rather be working on the example. So I'm going to comment out the previous line of code, keep this one running, and now our puzzle input there in the top right has the 6 lines of instructions from the example. I usually use capital N population size to get or record the length or number of instructions. So N will be 6. So now what we're going to look at is puzzle input are these 6 instructions that you see at the bottom left. If I look at the first one, nerdy note, R starts from indexing from 1. If I look at the first one, it has those words forward and 5. The idea is I want to somehow keep track of which word was there. Was the word forward, down, or up? And then after that, I want to be able to also grab the number so we could then do a calculation with it. Let me work in a new code block here. I foresee myself using some functions from the tidyverse, so I better load that in. And we're going to start. I envisioned the submarine taking its route over some time. So we're going to start with time equals 1. I'm going to use lowercase t for time. What I tend to do with these instructions, remember puzzle input 1, it says forward 5. I'd like to just look at one instance of splitting that up. We're going to split that between the word and the number. And one way to do that is in the string R package, we could use the string split command. Long story short, to the best of my knowledge, the string R package has several convenient tools for dealing with strings in kind of a computer hacky way, and they are useful for solving these computer programming puzzles. So I'm going to, for the puzzle input, I'll leave that as a 1 for now. Notice in between the words forward and 5 there in the bottom left, in between the words forward and 5, there's a space. So we need to tell R that we're going to actually do this split where the space occurs. So I'm going to run this line of code. I'm going to show you what this split looks like now. So now you could see in the bottom left that the forward and the 5 are indeed separated. Long story short, this structure at the moment is called a list of lists. It is useful for more complicated situations, but because we're only looking at one line of text, it's not helpful now. To focus just on this part, forward and 5, we're going to grab the first element of the list of lists, and that's done with these 2 square brackets around the number 1. So now, this time around, when I call this split, I have the forward and 5 without any additional adornments that might get in the way. Let's call the word this direction. That's going to be the first item in this split. Let's call the number move amount, and that's going to be the second item in this split. So notice there in the top right, this direction is indeed simply the word forward. Move amount is the number 5, but alas, it's still being treated as a string. Those quotation marks will get in the way. We need to coerce the result to be a number, and we could use a command such as integer to do so. So now we need to be able to tell and keep track of the submarine's total movements, the horizontal direction and the depth. Like the puzzle said, the horizontal distance is going to start at 0, and the depth is going to start at 0. A quick side note, for small words, I'd like to double check and see if they're used in the R programming language. And depth is a function name elsewhere. It's probably not a big deal, but I try not to accidentally use a word that might have been useful elsewhere. So I'm going to call this sub depth, the depth of the submarine, and we'll make that 0 as well. Now, with this direction, so word forward, and move amount, there in the top right is the number 5. We need to program and help the computer understand what's going on. We do that with conditional statements. So if this direction is forward, we need to take the horizontal distance and add the move amount. For those of you coming from another programming language, yes, it's kind of annoying that we do not have an increment shortcut, to the best of my knowledge. Alright, so similarly, if this direction is down, we need to take our submarine depth and add the distance that we're moving in the downwards direction. And then finally, if the direction is up, remember this is in the opposite direction of depth, so we're subtracting the move amount. Now, I'm just going to run this whole block, see how things are running so far, see if I made any typos or errors. And in particular, after the first step, we should have a horizontal distance of 5. And that's what we have there at the top right. Alright, now that this code can handle the very first thing the submarine does, I want to see if it'll run through the 6 instructions that we have in the example. So I'm going to wrap the main part of this code in a for loop. Now, in a lot of my previous adventures with Advent of Code, what I would forget to do sometimes is in my trials or my rough drafts, I started with just the first string, so I worked with puzzle input 1, but we have a counting variable t, so I got to put a t here in the first bracket. Do not need that t equals 1. That actually was not needed in the first place because of where I went. And for every step in the early going, let's go ahead and print the horizontal distance. And the submarine depth. I'm going to run this, and hopefully we will bring us to these numbers here that we see in the example. Running the code. We got a horizontal distance of 5, 13, and 15. We got depths of 5 and 10. And then, as the example says, we can now multiply the 15 and 10 to get the final answer. So the part 1 answer would be formed by taking the horizontal distance times the submarine depth. And that's the 150. These previous two print statements, I had them there to double check that the code was working. I'm going to comment those out. Run this all again just to see if everything's working okay. And to the best of my knowledge, we got the correct answer for the example. And now what I would do is toggle from the example to the real file and then run the code. So let me go ahead and do that. Let's go ahead and pat ourselves on the back for solving the first of the two puzzles for today. Let's see, where am I? Okay. Bring back my code, and we're going to now continue on to part 2. Based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is slightly more complicated. In addition to horizontal position and depth, you also need to track a third value, aim, which starts at 0. The commands also mean something entirely different than you first thought. So what the designers at Advent and Code, at least from the materials I've seen on YouTube, they intentionally do this. We, the puzzle solvers, solve part 1. We don't necessarily know what's coming in part 2. And it kind of, they say, simulates working in an environment where you're working on an engineering project and your clients, your supervisors, etc., all of a sudden change the scenario on you. So let's see what's happening now. Down increases your aim. Up decreases your aim. Forward does two things. Increases your horizontal position and increases your depth of your aim multiplied by x. Ooh. Again, note that since you're on a submarine, down and up do the opposite of what you expect. Down means aiming in the positive direction. I'm filming this overnight, so my brain is a little slow right now. Let me process this. Now, the above example does something different. Forward 5 adds 5 to horizontal position for a total of 5 because your aim is 0, the depth does not change. Down 5 adds 5 to your aim, resulting in a value of 5. Forward 8 adds 5 to the horizontal position for a total of 13, but because your aim is 5, your depth increases by 8 times 5 equals 40. Up decreases your aim by 3, resulting in value of 2. Down adds 8 to your aim. Okay, we'll work on that in a second. After these new instructions, you're still multiplying horizontal position and depth. Okay. So once again, I'm going to toggle on the example. I think most of the code is recoverable. Oops, and I still like to copy and paste the documentation. So what are the changes we need to make? Well, we need a variable for aim, which also starts at 0. I believe the horizontal is still the same, wasn't it? No. Horizontal increases your horizontal position as usual, but depth is increased by aim times the move amount. Okay. Down increases the aim, up decreases the aim, and I accidentally called this back up here depth, but out of an abundance of caution I called that subdepth. So once again I'm going to toggle on these print statements, which will help me as the for loop is running double check if the numbers are coming out as expected. So horizontal distance 5, 5, 13, 15 as usual, or as before. Depth got increased from 0 to 40, then increased another from 0 to 60, and we got the 900 that we see there in the bottom right. So I think I'm going to, if anybody is viewing this, show you the code one more time. Now that I'm at least assured that the code works on the example file, I'm going to bring in the real input, the 1000 submarine instructions, and see how that all works out. Whew. Got a number in the billions. Yeah, look at that. We did it, folks. We got the right answer. And that completes day 2. And I hope to continue right along. So if you have any interest in this, just let me know, and we'll see you next time.